Yeah.
from the ski slopes of,
All of
of
this.
Deer Valley, Utah.
You, we're in Alta today. Yeah.
So we appreciate your commitment,
Yeah.
Brian.
Yeah. I was gonna say you're the gonna be the world's greatest boss for taking over even part of this while I'm gone for an entire week. So anyway,
All right, cool. Let's switch to the deck here. Okay, great. So as a little bit of background here, let me introduce myself and Brian first, and then I'll give you a little bit of background about what we're talking about today. So my name's Sydney Lovely. I'm with Amazon Web Services. And Thomas had introduced himself earlier, and he works in the solution architecture team. I lead one of the media services for AWS called Media Connect. Brian Rundle is one of my senior engineers on the team leading this initiative. And background for me is I've been at AWS Elemental for about 2 years. Prior to that, I was head of engineering at Grass Valley for about 10 years. And prior to that, I was at Omnion Harmonic for about 8 years. So I've been in the industry for a minute or two. Brian has been at AWS Elemental for how long, Brian? Has it been?
7 or 8 years, something
7 or
like
8
that.
years. So he's been there a little bit longer. Prior to that, he was a software developer at Intel. And prior to that, he was also a software developer at Intel.
Yeah.
So
Quite a while.
So yeah, what we're going to present today is is an initiative that we brought to the VSF at the October New York meeting, which is the notion of an open source SDK to simplify connection management for ground devices and also to secure them. So for folks who aren't familiar, first a word here about AWS Elemental. So AWS Elemental makes a range of media services for the AWS cloud. So we sort of think about ourselves as kind of an end-to-end workflow. So you can see Media Connect forms the kind of front door to AWS. So we bring in RIST, SRT, TR07, other formats into the cloud. A typical workflow would be to go to Media Live, which is our distribution encoding, off to the packager, to Media Tailor for ad insertion, and out to consumers over CloudFront. We also, of course, support file-based workflows with our Media Convert file-based transcoder for those applications as well. So Media Connect, typical Media Connect use cases here, this is a simplified view of things, but it's not uncommon for folks to use Media Connect as the ability to insert live signals into VPCs, to work with partner applications, to extract those same live signals back to ground devices, but also to send those live signals cross-region. So Media Connect operates in 22 regions around the world. And also to send them cross-account through entitled workflows. So customers use that a lot to receive feeds from affiliates or to send feeds out to other affiliates. So the interesting thing is, out of all these workflows that customers can do with Media Connect, customers tell us that usually the hardest part of this is getting things connected to the cloud in the first place. And so why is that? As you can see, you have to, when you have devices on-prem, you have to have a sophisticated set of networking skills really to get things usually out of your corporate firewall, to set up security groups in the cloud. And there's lots and lots of great transport protocols out there, right? There's RIST and SRT, as we've been bantering on, over the last couple days, but also TR07, ZXI, other protocols. But they all still kind of really, still really require that networking skill to set up and to manage. And so a lot of the workflows we've seen customers do are kind of like nailed up 24/7 workflows, where it's a pain to get it set up, but once it's set up, you don't mess with it, you use an AWS Direct Connect, et cetera. But as customers are either doing more house of worship and simpler customers that are less technically sophisticated, or other customers that are doing more live production events, setting up and maintaining those connections quickly and easily is a problem. So the other thing that we often see, and it would shock you, but Thomas talked about security groups. So security group is our basically equivalent of a firewall in the cloud. And it'll shock you the number of customers that we help troubleshoot who have a security group of 0.0.0/32, right? So a lot of times folks just give up. So you imagine if you've got a device that you're using for an event, you get it all set up, You have to manage the public IP address, which has been natted from something on-prem, and then you go to use it a week from now, and that leased IP address has changed, right? And you got to go back in and change the security group. And so this is sort of a trade-off customers have to make between security and convenience, right? But there's a better way, right? We can use modern IoT technology to solve this problem in a way that's both convenient and secure. So this is something that we started looking at as an internal initiative, and we had thought about the possibility of just publishing this as part of the MediaConnect SDK, so folks could use it and connect with MediaConnect. And we talked with the VSF team in New York back in October and saw if there was interest in bringing this forward as a TR. There's really nothing specific about AWS or the cloud with this technology, and there seemed to be a lot of interest in this at the time. So we've since joined the GCCG group, brought this forward with Andy and team and John, and we've iterated on this, and what we're going to show you today is a demonstration of the current draft TR in operation on a real device running to the AWS cloud. And then Brian will walk you through a high-level walkthrough of the technology, and then we'll talk about timelines from there. Okay. So
Sydney,
Brian,
I cannot see your presentation. It's not being shared right now.
okay. So let's see here. Thank you. Let me turn on my screen share. Can you see me now?
Great. I can.
Okay, great. So Brian, I'll let you take it from here.
Okay, great. Okay, so yeah, so I think what I'd like to do here is to dig into some of the technical details about what we're proposing and what we built, and sort of lead into the demo so that the demo makes a little bit more sense. Basically, we're trying to standardize around all of the components that are necessary to make that connection and discovery easy. So there's three pieces that we think are part of that standardization. One is the discovery and pairing process. So that is how to take a client device from basically an anonymous thing on the internet to something that's trusted and has an identity and can subsequently communicate and be secure. The second piece that we want to standardize is the communication methodology. So whether it's going to be HTTPS or MQTT, precisely defining how the communication will happen, part of the specification. And then finally, we want to standardize the payloads. So the actual payloads that get communicated back and forth for things like reporting status or pairing process or communicating to the device a new configuration update, just let's say start the device. So once those things are all standardized, then we get to the second part here, which is what we want to provide. To make this easier and to make it easier to understand what we're providing and to also lubricate the adoption process, we're releasing an open source client SDK that will work out of the box as a client. To make it even easier to understand, there's a client application reference design that sort of simulates a device like an encoder using the SDK. And then there's going to be a service endpoint, a reference design service endpoint that'll simulate the cloud endpoint. So that the full system is something that can be downloaded and enabled and turned on and running in a matter of minutes. And then, of course, lastly, the protocol and the API definition. That will be the documentation that describes how it works. So somebody could take the open source client SDK and rewrite it or change it, provided they still abide by the protocol and the API definition, then that's fine. So the demo that I'm going to show you is in a couple parts. One is sort of it's like a before-after demo. The before case is sort of what people would experience today when managing a remote device, and then I'm going to show you what we propose to do. So a brief description of sort of the steps that are involved. We think about it sort of in three phases, sort of like a setup step where you're trying to gain access to the device. Then there's a running phase where you're actually running a streaming workflow, and then there's the tearing down process. And it goes sort of something like this. You need access to the local VPC in which the device resides. So you can maybe tunnel into that, or maybe you know somebody who's in the network side of that building where it operates, and you can make a phone call. Then you're going to find and log into that device. And to the extent that you want to configure it and set it up, you're going to be using that device's bespoke user interface. And if you have 6 or 7 or 8 different types of encoders and decoders out there, someone's going to have to be an expert in generally all of them. And so that just adds a little bit of maybe delay and possibly confusion. And depending on if there's multiple players involved, if there's a cloud person involved setting up, let's say, the cloud destination, and then there's a different person involved in setting up the device, you'd have to convey those params verbally or via email or just copy them if it's the same person. Then when it comes to running and tearing down, it's, you need to stay logged into that thing. If you really want to have visibility into what's happening on the source device, that access that you gain from tunneling in and logging in is got to stay persistent. Otherwise, you're not necessarily going to see things like thumbnails. So the summary problem statement here, thanks. That sort of access pattern fundamentally is it's challenging, but more importantly, it doesn't scale. If you're talking about maintaining a fleet of devices, just knowing where they are requires some form of spreadsheet to hopefully keep up to date on the IP addresses and the usernames and the passwords, and that presents its own security problems. Like I said earlier, there's central monitoring is a problem, setup is slow, and then finally, those devices are not necessarily portable. If you have an IP address for a device, that only works when that device is static. If you move it to another building, all bets are off. Managing a remote device, I think what we're trying to show here is it's substantially more easy, simpler. The setup is a one-time process where you pair the device into a cloud registry, kind of like you're running a pairing code process to register Netflix on your Roku into your account. Running it is all from the cloud, so you're basically assigning a destination and starting it, and that can be done in a highly automated way because the cloud endpoint that's controlling that also knows about those destinations, so it can programmatically inform a device how to set up, for example, an SRT configuration, including password, without any user involvement at all. And tearing down is also from the cloud, and you just simply stop. Again, the benefits from here are, like Sydney alluded to earlier, secure modern registration process that's based upon the OAuth standards, the automatic connection management, and then once you're in the monitoring phase, you will be able to see real-time telemetry from the device because it's sending it at a high frequency, including things like thumbnails.
And I guess I'd add to this as well. For some customers, this is a convenience. For other customers, it's a necessity, right? So we have customers that are interested in, for example, bringing a whole bunch of feeds in from traffic cams all around a city into the cloud to do their news production, right? They don't have easy access to those devices. They need to manage them remotely from the cloud. We have other customers that run like US station groups where they don't have very sophisticated operators on the ground. They can deal with basic SDI infrastructure and that's about it, right? So they want to manage everything and all the devices from the cloud for maximum flexibility. So enough talking about it. We'll run through a demo now, but unlike my esteemed colleague Phil, we're not going to do this one live. I asked Thomas about this, and his advice was pre-record your demo.
Yeah, that was fun.
All right,
so the feedback we've gotten so far on this demo is that my face is too big.
So this is so Brian's going to step you through the process, and he. I think, Brian, I think it's fair to say that you're not going to be a professional YouTuber anytime soon. Is that right?
No, I'm going to get some training, maybe. Yeah.
Okay, let's roll.
I'd like to talk to you about the Client Device Discovery SDK and give you a short demonstration. We'll start with a brief problem description. And for the demonstration, part one will be the before case, how today streaming workflows are set up, managed, and torn down. And the second part of the demo will be the after case using the Client Device Discovery SDK on that same device. Firstly, this demonstration is not about transport. There are many existing open source and proprietary protocols for delivering low latency, resilient streams across the internet. Our solution is not about transport, it's about control. The Discovery SDK is about how to manage devices. So we're talking about passing configuration, getting status updates from the device, thumbnails from the device. This is a discover, connect, and communicate protocol. Primarily, we're interested in how to make it very easy to find, set up, and control existing devices. So telemetry, status, configuration, thumbnails, that kind of payload. Okay, let's start the demonstration. On the right, you'll see the AWS Media Connect user interface. Here I'm showing a flow that is an SRT listener. On the left is a web browser that I'll use to access the encoder that's sitting in a facility in Portland, Oregon, behind a firewall and a VPN. On the bottom left is a spreadsheet that a company might typically have to keep track of where all their devices are, their IP addresses, usernames, passwords, that kind of information. For this demo, I've already successfully tunneled into the facility, but now I need to find the device and access the device to get started. So I'll look at the spreadsheet and find the device IP address. Now I can log into the device. Okay. What I want to do is configure an SRT stream. So SRT listener in the cloud, SRT caller from the device. So I'll go into the channel page and select transport stream over SRT. And at this point, it's about copying parameters from the destination to the device. Fortunately, I have access to both the cloud console and the device console. So for me, it's a matter of copying and pasting parameters, which is fairly straightforward. In other cases, there are two people involved. There's a ground operator and a cloud operator, and they have to communicate those parameters successfully. That can be a little bit challenging, especially for things like 32-character encryption keys and other things which are easier to get wrong and harder to debug when you've got them wrong. Okay, I'll copy the IP address first. I'll select SRT caller. Paste the IP address, the port is correct. The stream ID, type that. Discovery 1. And I'll pick a different latency, let's say half a second. I think that's right. So I think the parameters are matched between the source and the destination, and I can now hit start. So the channel is starting, and I would expect to see streaming video, in this case a thumbnail in Media Connect. Okay, now the stream is started. Ideally, I'd like to centrally monitor all my streaming workflows from the cloud. That includes the on-prem sources like the video encoder. But in this case, to see what's happening on the device, like debugging a bad input, for example, I'd have to re-access this device in the future. So I'd have to tunnel into the VPC and find the username and password and IP address and log in and look at what might be happening there. Look for a thumbnail, look for a downed input. Doing this on multiple devices for multiple streaming workflows is very slow and impractical. Finally, to tear down the streaming session, I have to re-access the device again and select stop. Okay, this is part 2 of the demo. This is the after case where I'll demonstrate the client device discovery SDK. I'm going to begin by showing you the pairing process. That's how you connect a device that's never been connected before and have it claimed in a service account. And then I'm going to show you how you can easily start and monitor a streaming workflow from the cloud. To be clear, the SDK is a tiny program. It's installed on an encoder, decoder, or even a camera. It handles the pairing process, the authentication, secure communication with the cloud service, and it continually transmits telemetry to the cloud and is promptly updated when a desired configuration is given. Modern industry standard secure protocols like OAuth, HTTPS, and MQTT. On the right is a demonstration cloud discovery user interface. On the left, we still have our encoder device. This time it is running the discovery SDK. And on the bottom right, I've shown the same Media Connect SRT listener flow, and we'll use that for streaming later on. Okay, let's start the pairing process. I'll select System Discovery, and this brings up a concise control panel for managing the Discovery SDK. It's fairly simple. There's a connection, enable, disable. You can select the host service that you're being discovered into, and then 3 simple status fields: a connection status, a pairing code that's presented during the pairing process, and a device ID for when the device is connected. Okay, to start the pairing process, I'm just going to select enabled. At this point, the SDK has contacted the cloud service and obtained a short pairing code. I'm going to copy that pairing code and put it in the Discovery console and claim the device. So the device has now been claimed into my account, and as you can see, the display is showing connected, showing the device ID, and on the service side, this green device is in my Discovery registry. And when I click on it, I can see the status, input status for HDMI and SDI inputs. It's active on the SDI, and I can see channel status, and right now everything is idle. That's it. The device has been discovered. It went from being an anonymous client on the wild internet to now having the certificate and identity required to reconnect in the future. And I'll show you that now. At this point, you could power down the device or simply disable the connection, and immediately that device shows up as offline in the service. Because we've already done the pairing process, to reconnect, it's automatic. Select enable. And using the identity and certificates that it acquired when it paired, it recontacts the service, and now we see the device is online. Finally, let's get to starting a stream between the device and our online destination. So this is easy, and no device access is required at this point. I can do everything from the service. My Discovery console already knows about all of my cloud destinations. So I can simply select Media Connect flow that has an SRT listener input and update the device to stream to that input. That's it. There's no parameters that need to be passed to the device. As you can see, the device is already started and the thumbnail is already being sent. The last thing I want to say is that monitoring the device from the cloud is possible. I'm showing here the channel is in an active state. The video bitrate is being updated in real time, and I can see the video metadata and audio status for all of my workflows, including sources. And finally, stopping and tearing down the workflow can also be done from the cloud. Simply select stop. I can stop configurations past the device, and the device stops. You can verify that by seeing the active state here go to idle.
Okay, well, thanks, Virtual Brian, for that. So I think we have a little segment here where you'll walk us through a very high-level guided tour of the components of the technology that are in the draft TR.
Yeah. So I think this was covered fairly. We could maybe skip over this one, Sydney. It's just basically showing the components. I'm going a little bit deeper into the networking protocol. What we've done is decided on 2 approaches here. For the pairing process, it lends itself to a REST API. So that will be hosted in the protocol over HTTPS, just a simple REST API. And then once the device has been paired and has certs and has an MQTT endpoint, then from then on it's communicating completely through MQTT. Both of those can be done as far as the firewall is concerned through port 443, where only outbound and then reply is enabled, which is pretty common for a lot of networks. So you don't need to know the device IP from the outside as long as the device can reach the internet and that a port 443 request outbound is permitted, then everything you've seen is permitted. The registration and pairing process, this could be more or less a diagram for OAuth. We've spiced it up a little bit to add some security, but basically what you'll see here through these 7 steps is that the SDK is started, the device makes a request from the service for a pairing code, that pairing code is communicated somehow to a cloud operator out of band, that cloud operator claims the device, and then subsequent requests by the SDK for credentials are now responded to because it's been claimed. And that response includes an identity, X509 certs, and the MQTT endpoint that it should talk to. It's interesting that in that response, the MQTT endpoint is a regional MQTT endpoint, so that it's not given its final destination or connection until it's been claimed, because typically in cloud methodology, you're logged into in the cloud into a specific region. So when you claim a device, you're effectively claiming it into that region. And then the certs are saved on the device. The next slide here goes over a little bit of the integration model. It's fairly straightforward. The pairing and control, like I mentioned, are over HTTPS and MQTT. Within the device, though, the SDK will be a C++ or Python SDK. Currently is Python. The IPC between the host process, like the encoder and the device, is via REST. The device manages the SDK process, so the device will launch the SDK process and then communicate with it over REST. So very high level of interoperability and commonality for systems to be able to do that. Something we might even consider here is having this launch within a Docker container too. And then finally, the SDK just needs access to a file path on the system where it can read and write certs.
Yeah, and I think that's an important point to touch on, right? So while all the networking connectivity has been kind of wiped out, you still need the pairing code process. And the last thing you want to do is make the customer have to repair if say the device went offline, during a live event and they had to reconnect it. So the certs are stored and the certs are automatically rotated from the service at a time of your choosing, right? So you could choose for fast rotation or slow rotation. But that's an important point to point out, is that the pairing process is a one-time process.
Yeah, there's a lot of things where the rubber meets the road. When you say the word, modern process, there's a lot of things that are required of the SDK that come from experience in managing devices, so fleets of devices from the cloud. This methodology and the protocol bakes a lot of that knowledge into it that we've gained over the years, and certainly rotating certs is a big piece of that. The SDK will, of course, handle all that, so there's not a complexity that the device integrator needs to worry about. All they need to do is provide a file path, and the SDK will handle that.
Okay, great. So a couple practical matters here, right? So first, as I mentioned, there's really nothing AWS centric about this technology. So the device SDK is all built from open source libraries. Brian, is the VSF GitHub up yet, or is that pending still?
I am waiting for AppSec to approve it. I've been hounding them.
Okay, so yeah, we're on the cusp of publishing this to the VSF GitHub repo. That'll include the device SDK. It will also include a reference design, so you could download it, put it on a device, as well as a reference service. So you can basically take a CloudFormation template and spin it up. If you want to, and then the open source spec as well. So our intention here is there's really nothing AWS centric about this, certainly not in the device or in the specification. So if you wanted to build a backend orchestrator to control your devices on-prem or in another cloud, that's totally up to you, right? So our intention here is for this to be fully open. From a timeline standpoint, last year we were kind of in this concept stage where we had a concept draft proposal, device SDK, and some initial amount of device integration, as you've seen. So we've now moved into the draft TR stage. So we've sort of started that process this year with the GCCG team. We're also moved into this beta stage, right? We're now the device SDK will be available on the VSF GitHub. and device integration starting with partners already, as you saw. Brian was demonstrating it with one partner. So, and the cloud service itself is in this beta prototype stage. Ideally, we'd like to close the draft TR and not have it drag on forever. Try to get this driven to closure in about 6 months. And then move into a limited availability stage where we'd like to prove it on air with real live broadcasters. And ultimately resulting in a full GA for the full stack NAB a year from now. So my ask of all of you and call to action here is really threefold. So first, for VSF members, for folks who are interested in contributing to this and improving it, please join the GCCG activity group and help us improve it and make it better. For folks who are device manufacturers, download the SDK and reference designs and try them out. Our goal here was to make this super low drag to integrate, and hopefully something can be done in a matter of a few hours. And then for broadcasters, try a proof of concept with the reference service and devices, right? And help us improve the offering. This is something that we don't want to have it be an owned proprietary thing. This is something we think can benefit the industry at large, but we need your help to make that happen. Okay, I guess with that I'll take questions. Mr. Edwards has a question for us.
I've got a question, Sydney. Thomas Edwards, Amazon Web Services. Can the pairing codes be pre-published? So if I was a vendor and made encoders, can I just hand you a list of 100 pairing codes so that you don't have to log into the devices to get the pairing codes? Or is there a cryptographic thing that's going on there?
So, so Brian, did you hear the question, or shall I repeat it?
I did, yeah.
Okay.
Yeah, I did. That's an interesting approach. I would say the only thing preventing it is that pairing codes must, by their very nature, be time limited. So I don't, what you're describing is probably something where those pairing codes have to be unclaimed for quite a while. Generally, that's not acceptable for the OAuth standard. Probably wouldn't be approved as part of a standard cloud offering, because once those get out, those could be used to, claim that, have your device being warmed into somebody's network that wasn't really intended to. The idea, though, of providing a pairing code where the person on the device doesn't have to do anything, I'll look into maybe some possibilities for doing that. It would have to be under that very time-limited pairing code expiration. We're talking on the order of maybe an hour or less.
Yeah, and it's, I guess we should also, Brian touched on this just briefly in passing, but also we should mention that this whole thing's been through the full Amazon security review by our stringent security team that Thomas was mentioning earlier, that regularly chews him out for having open ports. So,
yeah.
So we do think that the one thing that's a little bit of a variable is how long the credentials persist for. Right, and it's really difficult, right? Some people will be very security minded and want the credentials to rotate out very, very quickly. Other people will want them to rotate out more slowly. So it's up to however the customer wants to implement it. So our notion here is that cert rotation will be customer specified, at least for Media Connect. If somebody else wanted to offer a different experience and have their own management tool, they could do whatever they wish, of course, right?
Yeah, I mean, OAuth sort of requires that the communication between the device side and the service side of that pairing code be done by somebody who's going to be authorized to do that. So you can imagine writing a simple piece of code on top of the SDK that transmitted that pairing code rather than have to rely on communication via text or having both. That would be fine. It'd be outside of the protocol for obvious reasons, but completely possible to enable what I think you want, which is start the pairing process. That device automatically sends an email with the pairing code in it, and provided it's claimed within a certain amount of time, then that should work.
Okay. Looks like we have another question from Ciro.
Yes, thank you. Ciro Noronha, Cobalt Digital. So the example you gave is with an encoder, and looks like the only thing I saw there is the bit rate. There's a myriad of parameters that you can set on an encoder, and that varies a lot from vendor to vendor. What did you do about that?
Yes.
No, that's, yeah.
Go ahead, Brian. If you caught that, I'll let you answer it.
I did. Yeah, I did. No, that's a good question. So part of the protocol that we're defining that we didn't really show today was precisely what is that definition for how you control an input or a channel or an output. What params would we want to allow? The first priority here is not to try to be everything to every device. And one path that we're going to try to avoid is to have the protocol simply be an open specification so that somebody could completely expose every single setting that they had and that would be visible in the cloud. The reason that that's a problem fundamentally is that the cloud operator is likely going to be exposed to a variety of devices. And it's really important that there's some standardization on that side. So a standard set of control and status parameters. So the very first thing we want to do is create a standard set. And necessarily that means some level of restriction over what you've mentioned, that, you know, there's everything under the sun. So we'll probably end up, as part of this process of defining the TRs, closing in on what that set is, where it's not trying to boil the ocean. It makes sense for what cloud operators would likely want to see, but it will not be a full cockpit for a decoder. Those can get extremely complicated. So I don't think it would be that. The protocol is in the form of a JSON schema that has at the first pass a very, let's say, a broad spectrum of options that are available for configuration and status. And then that schema, before it's actually implemented on the device, can be scoped down. So the device operator can indicate that they only want to have a subset of that schema. So for example, the protocol schema might include cameras, encoders, decoders, and 100 different settings. The device operator can say, look, I don't want to expose 100 of those. I just want to expose these 6 or 7 settings. And provided, as long as that schema is a subset of the protocol schema, then that's allowed. The service is going to be able to handle it. The protocol sort of absorbs that complexity. I think the takeaway is we're not going to try to have every setting available in the cloud. It will be some form of something that we decide.
Yeah, I mean, my simpler answer to that is that we're really focused on discovery, connection authorization, and connection management, right? And so it's really the parameters that will be exposed as a first-class citizen will be connection-oriented stuff, right? Like codec, transport protocol, bit rate, et cetera. And then there'll be a generic extensible schema, because now you have a secure communication channel set up for the device that customers can build on top of. And we'll expose, at least for the Media Connect implementation, we'll expose that through our API, so you can build on top of it. But you know, we're not attempting to do, you know, all of the device control and everything that you do with like a Katina, right? That could easily be built on top of this communication channel if folks want to do that. And so we're trying to constrain this specific TR to be really connection oriented, but it could certainly be built on with a future TR.
Okay, so minimum set of parameters that just enough to get it connected, and that's that. Because it's impossible to use.
Yeah, well, you know, as you can imagine, our canonical use case here is a contribution encoder, but it could just as easily be a camera or a graphics engine or a production switcher or anything, right? And so, you know, so getting into controlling all those parameters is a different kettle of fish.
Even on an encoder, is it 42? Is it 40? Is it 10-bit? Is it 8-bit? Is it?
Those are the settings that we've looked at that likely make it into the spec. Those are fairly standard encoder settings that picked up.
And those are some of the things that we're trying to run to ground in the GCCG AG. Right? What's the right level of granularity to provide, you know, as properly